In this video, I'm going to talk about understanding controller discovery. Cisco lightweight wireless access points need to be paired with a wireless LAN controller or WLC to function. Each lightweight access point or LAP must discover and bind itself with a controller before wireless clients can be supported. Actually, Cisco lightweight access points are designed to be touch-free so that you can simply unbox a new one and connect it to the wired network without any need to configure it first. Naturally, you have to configure the switch port where the AP connects with the correct access VLAN, access mode, and inline power setting. From that point, the AP can power up and use a variety of methods to find a viable WLC to join. First, let me to explain about the AP or access point states. From the time it powers up until it offers a fully functional basic service set or BSS, and lightweight access point operates in a variety of states. Each of the possible states are well defined in the control and provisioning of a wireless access point or CAPWAP RFC, but are simplified here for clarity. The AP enters each state in a specific order. The sequence of a state is called a state machine. You should become familiar with the AP state machine so that you can understand how an AP forms a working relationship with a wireless LAN controller. If an AP cannot form the relationship for some reason, your knowledge of the state machine can help you troubleshoot the problem. CAPWAP is defined in RFC 5415 and in a few other RFCs. The terms used in the RFC differ somewhat from the ones used in a Cisco Unified Wireless Network and this video. For example, access controller or AC refers to a wireless LAN controller, whereas wireless termination point or WTP refers to an AP. The sequence of the most common states, as you can see in this figure, is as follows. Actually, here we are learning about the AP states from step 1 to step 8. In step 1, as you can see, the AP boots up. Once an AP receives power, it boots on a small iOS image so that it can work through the remaining states and communicate over its network connection. The AP must also receive an IP address from either a dynamic host configuration protocol or DHCP server or a static configuration so that it can communicate over the network. This is the first step. AP boots up. The second step, as you can see, is the WLC or wireless LAN controller discovery. The AP goes through a series of steps to find one or more controllers that it might join. The steps are explained in this video. After that, we have CAPWAP tunnel. Step 3. The AP attempts to build a CAPWAP tunnel with one or more controllers. The tunnel will provide a secure datagram transport layer security or DTLS channel for subsequent AP wireless LAN controller control messages. The AP and wireless LAN controller authenticate each other through an exchange of digital certificates. It means that first the AP boots up, after that we should find the wireless LAN controller, and after finding the wireless LAN controller we establish CAPWAP tunnel with DTLS, and after that we can use this CAPWAP tunnel for exchanging the control message securely between the LAP and also wireless LAN controller. The next step is step 4 and WAAC Join. The AP selects a wireless LAN controller from a list of candidates and then sends a CAPWAP Join request message to it. The wireless LAN controller replies with a CAPWAP Join response message. In this video, we will learn about how AP selects a wireless LAN controller to join. It means that if we have, for example, 2 wireless LAN controllers, finally LAP should choose one of them and send WLC join message, join request message, and after that it should receive the wireless LAN controller join response message. Okay. We will learn more than this about this step. After that, in step 5, download image, the WLC informs the AP of its software release. If the AP's own software is a different release,